Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. You can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer at these links. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. And here's a problem for today for exam IFM, Investments and Financial Markets. For a two-period binomial model, you are given that each period is 6 months. The current price for a non-dividend paying stock is $70. U is equal to 1.181, where U is 1 plus the rate of capital gain on the stock per period if stock price goes up. D is equal to 0.890, where D is the 1 plus the rate of capital loss on the stock per period if stock price goes down. The continuously compounded annual risk-free rate is 0.05. Calculate the current price of 1 year American put option on the stock with a strike price of 80. And here's the solution. So first we construct the two-period binomial tree. The stock prices at various nodes are S sub U, which is the price if the stock goes up, which is 70 times 1.181. That's approximately 82.67. SD is the price if the stock goes down, and that's 70 times 0.89, which is approximately 62.30. SUU is the price if stock goes up and then up, and that's 70 times 1.181 squared, approximately 97.6333. SUD is the price if the stock goes up and then down, or it's the same if it goes down and then up, and that is 70 times 1.181 times 0.89, and that's approximately 73.5763. And SDD is the price if the stock goes down and then down, and that's 70 times 0.89 squared, which is approximately 55.447. And we have the following tree. At time 0, the price is 70. At time 6 months, the price is 82.67 in the up state and 62.30 in the down state. And the time at time 1, at 1 year, the price in the up state is 97.6333. And the payoff of the put in that state is the maximum of 80 minus 97.6333 and 0, and that's 0. The put has no value because you can sell the stock in the market for a much higher price than 80. And the price in the state of up, down, or down, up is 73 of the stock is 73.5763. The payoff of the put is 80 minus 73.5763. It's actually the maximum of the two, but it is equal to 80 minus 73.5763, and that's 6.4237. And then the down state, the price of the stock is 55.4470. And the payoff of the put is at 24.553. The risk-neutral probability for the stock to go up is e to the r minus delta h minus d over u minus d. That turns out to be approximately 0.465. If the option were European, then the value of the put in the up state would be the discounted present value, discounted over one period, expected present value, discounted expected present value under this risk control probability. So it would be PUU times P star plus PUD times 1 minus P star, and then discounted over 6 months, half a year, at 5%. And that turns out to be approximately 3.3518. And in the down state, e to the minus rh times PUD times P star plus PDD times 1 minus P star. We plug in the values, and this turns out to be approximately 15.7248. This is an American option, though. We're going to compare these values with the value of the option if it is exercised at time point 5, which is K, the exercise price minus S.5 plus, so the maximum of those of K minus S.5 and 0. And that's equal to 0 in the state where the price of the stock is 82.67. But in this state where the price of a stock is 62.3, the immediate exercise produces a payoff of 17.7, which is more than 15.7248, which is the expected present value in that node, in that state of the future payoffs. So the value of the option at time point 5 after one step is 3.3518 in the up node and 17.70 in the down node, and 17.70 comes from immediate exercise. And the value of the American put at time 0, if we don't pay attention to the immediate exercise value at time 0, so let's just calculate the expected present value of the payoffs, future payoffs at time 1/2. It's discounted, probability weighted average of 3.3518 and 17.70, and this turns out to be 10.7558. And we compare it to the intrinsic value of immediate exercise of 10 at that time, and conclude that the price of the option is 10.7558 because that's more than the intrinsic value of 10. And that's answer D. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.